Hey, everybody, this is Alex Merced from, Data Nation. That's the podcast you're listening to, right? Anyways, what I want to talk about today is a new blog that I've written. It's about the Kafka Connector for Apache Iceberg. And I got to play with it. I basically spent quite a few days getting it all set up, and it's all documented in the blog. I tried to set it up in a way that anyone could just spin up the Docker container, follow some very simple steps, and see it in action and kind of understand it. So I highly recommend if you've never used Kafka Connect or Kafka and really want to, get a deeper experience with it, to try it out. I think it's a good introduction. I will have a link to all that exercise, the Kafka exercise, along with many other exercises in the episode description. But I'd like to do is just kind of lay out some of the conceptual ideas so that way as you go through the exercise, you see what's kind of going on. So there's a couple different pieces going on in the exercise. There's going to be Kafka. So again, Kafka can be thought of a lot of different ways. What it is, it's a message broker. So the idea is that it's a platform that can receive messages and deliver messages. And sort of one of the coolest use cases of it is that you could have a lot of independent services that need to communicate with each other without directly communicating with each other. They just know that, hey, I have to go. Like, for example, if you didn't have Kafka and I had like 10 different services that had to work together, I would have to hand code how each service talked to each other service. And then if one service changed, I would then have to update how all the other services work relative to that service. Okay, so the idea is there's a lot of more interdependency. But with Kafka, essentially everyone speaks a sort of uniform language. They speak in the language of Kafka topics. So basically, what would happen is that let's pretend that I have three services, and let's pretend it's like as a sign up process. And basically, what would happen is that the user will sign up, and basically, maybe the first thing that happens is we create the user in the user database, and that's event number one. Okay, so it'll happen is that first that data gets, so basically what generally would happen is that first there's the actual like sign up service that captures the information from the user in the form. Instead of sending it directly to the database, they would send it to the Kafka message broker as like a sign up topic. Okay, and then the registration service would then go check the sign up topic to see, hey, are there any new signups? Oh, there are new signups. So basically it would periodically check for new signups, or in some sort of way be notified of those signups, and then it would take that information and then go back and put it in the database and register it. And maybe there's like some third process. So maybe there's like a background check process or something like that. So then what would happen is that basically that service would then maybe go put the end result of the registration and put those details in the background check service. And then the background check service would check that topic, collect that information, and then when it's done, put it in like a complete queue. And then basically the original sign up service will just keep checking that complete queue to see if that sign up has been completed. Okay, so this way it's not like you're not, you basically, again, each step is just sort of independent, and basically it's done because eventually that particular sign up shows up in that complete queue. Okay, and again, this is just sort of one example, but then again, later on, it does change how the background service works. It doesn't change how those other services have to do anything, because they're just expecting to get data from a particular queue and to deliver it to a particular topic. Okay, and the topics are the different sort of, think of them as like, they're not tables, but they're like the equivalent of tables in the Kafka world. Essentially what they are is just basically a bunch of messages Kafka's received in order that you can then receive. That it can be organized by keys. Let's not get into those kind of details. But essentially that's what Kafka is. Essentially it can deliver, but it's very popular for like streaming data. Because again, with streaming data, you have a lot of different applications sending in different events. And what they can do is they can just send those messages over to Kafka with details of those events, usually as like JSON strings, and then other services that need them. So you may have several different services that need them. They can all just go request that data from the Kafka topic on the other end. Okay, so basically any other service can then go get that data and get it real time as those messages are coming in, and then process them. So that way you can do sort of in-stream analytics. So that basically even before you save that data in a database somewhere, you can start collecting those messages, forming them into sort of like tables that cover that particular period of time, run a query to generate sort of metrics on the fly. So imagine that you have like a Kafka topic, and then you have a system, a thing that's kind of, you have one service that's just kind of collecting that data and putting it into a historical table for a much longer term historical analysis. And then maybe you have like separately like a Flink cluster that is grabbing like the last 5 seconds worth of data, doing some sort of like average, some doing some calculations to generate like a number of like, hey, what is the average price for the last 5 seconds, and then sending that out to feed some other system that is building sort of a live view of that. Okay, you can have all these things because these things can work interdependently, because they're just pulling in the messages from the same Kafka topic, and that message is there for anything that needs it. Okay, so now that we've kind of explained sort of like what Kafka is, let's just talk about sort of like where Kafka Connect comes in. Well, a typical use case is you want to take the data that's in a Kafka topic and deliver to some sort of destination system, whether it's a database, a data warehouse, or the data lake. And so in that case, these destinations are referred to as sinks. Generally you have a destination and you have a sink. Okay, in the stream world, and a sink is generally you're syncing the data into that destination. Okay, so in this case now there's a Kafka Connect Apache Iceberg sync created originally by the people at Tabular. Okay, the Iceberg catalog company, or an Iceberg catalog company, and they built this connector, and it's pretty neat. It's pretty cool, and they're contributing it to the Apache Iceberg project, and it works with any catalog, which is pretty cool. So essentially the way it works is you have the topic. So basically you're going to configure a lot of things. You're going to configure, hey, what is the source topic? So you'll sit there, and you can actually have multiple connectors. So again, each connector, you would submit different JSON configurations. So the way Kafka Connect works is like it's a separate service, and then you would say, hey, I have this connector, this sort of job I want you to do Kafka Connect, and here are the details, and you send it to it as like a JSON, a set of JSON to it. In the tutorial, we do it as properties because you're essentially kickstarting the Kafka Connect with this job already in mind. So you can actually put it in a properties file and then kickstart it with that properties file, and it'll run. But usually the Kafka Connect cluster is already like running. So in that case, you can't restart it just because you want to send it a job. So the way you would do that is you actually make an API call to an endpoint to send it the details of the job as JSON. So in these configurations, you'll configure things like all your normal catalog configurations that if you've ever worked with like Apache Iceberg and most tools, you've had to configure your catalog details. So you're probably used to that by now. Basically, hey, what catalog am I using? Is it Nessie? Is it JDBC? Is it REST? Whatever. What are the authentication details? What is the storage details? All that fun stuff. Then you have basically, hey, what is the source topic? What is the topic with the data that we want to ingest? There's also something called the control topic. So the way that this particular sync works is that you might have multiple workers. So workers are going to be, and again, in any multi-node system, you're going to have a coordinator who just kind of like coordinates the job, but then you have workers who are actually doing the work. So you can have multiple workers who are reading the topic and then writing data files. Okay, and the coordinator is a topic within Kafka. It's used to track, hey, which data files has one of the workers read. So this way the workers don't end up writing the same data to multiple files. They're aware of what each other's done because they can check the control topic. So the control topic isn't the data you're ingesting. It's another set of data to make sure that these workers don't overlap with each other. And then what's going to happen is that at a period of time that you can set, or after a certain amount of data has been ingested, then what's going to happen is that the coordinator of these is going to get notified saying, okay, and again, also through the control topic, we'll get a notification of, hey, it's time to commit. So essentially, when it comes to the actual commit to the catalog, so basically all these data files were written, the coordinator then will go write the metadata on top of those files that were written by the multiple workers and then make the actual commit to the catalog. So basically, the actual catalog commit process is only being done by one node, while the writing of all the data files can be done by lots of nodes. But also really cool is like things like, hey, you can do automatic schema evolution with this. So basically, and it's only in one direction. You can add columns, but it won't take away columns. So if it notices that, hey, future Kafka topics have a column that wasn't there in the past, it will add that column to the table automatically if you choose to enable that feature. You can enable auto create tables, so that way it creates the tables on the fly. So that way, if the table doesn't exist, it'll create it. You can enable dynamic writing. So in this case, instead of saying, hey, write all this data to this particular table, what it will do is you can actually specify a field. So imagine that you have like in the example that I do in the exercise, is you have a transaction stream. Okay, and some different transactions represent different things. Like one may be like a refund, one may be a purchase, one may be a bill payment, but they generally are all kind of like, hey, money was sent to at this date. Okay, so you might have this transaction stream that's capturing all transactions within the business, but you want those different transactions in different tables because they represent really sort of different things you did. Paying a bill is not the same thing as being paid on an invoice that you sent to a client. So you can have that column. So you have that one topic that captures all these events, but then you can then stream them into different tables pretty easily using that dynamic write functionality. So it's actually really cool and works once you kind of done it once. It's actually pretty easy to use. So I highly recommend. Again, in the video description you can find the blog, which with the hands-on exercise it'll walk you through step by step. And it's a setup that's supposed to be like easy for you to experiment with. So I try not to abstract too much away. So that way, I always like to make sure that you can see the guts. So that way, if you want to like tweak it and change it, so you can learn more, you can. But again, you'll find that all in the episode description. I'll see you all in the next one. Have a great day and enjoy.